Hello, my dear students. I hope you all are fine. I'm Ashwara here to teach you mathematics chapter factors and multiples. But before starting our chapter, please subscribe our channel and don't forget to press the bell icon for further notifications. Now, students, before starting our chapter, tell me, do you know about these points? I think yes, you all have studied these in previous classes. First one is integer. An integer is a number that can be written without a fractional component. Example minus 3, minus 2, minus 1, 0, 1, 2, 3. Here in the example, we have seen that integers consist of both negative and positive numbers and 0 also. Second one is natural numbers. It consists of all the positive numbers. Example 1, 2, 3, 4, and so on. Now, our next point is whole numbers. These are the basic counting numbers like 0, 1, 2, 3, 4, 5, 6, and so on. These all are known as whole numbers. Now, our next points are even and odd numbers. You all know very well about these. So, an integer that can be divided exactly by 2 is an even number. Example 0, 2, 4, 6, 8. Now, odd numbers. These are the integers that cannot be divided exactly by 2 are known as odd numbers. Example 1, 3, 5, 7, 9, and so on. So, these are some basic concepts. Now, we will proceed to our topic factors and multiples. A factor is a whole number which divides exactly a number leaving no remainder. Here I have given one example. Now we know that 15 equal to 1 into 15 and 15 also equals to 3 into 5. This shows that each of the numbers 1, 3, 5, 15 exactly divides 15. Therefore 1, 3, 5, 15 all are factors of 15. Now a factor is always less than or equal to the given number. Now we proceed to our next topic, multiples. A multiple is always greater than or equal to the given number. Multiple of a number are obtained by multiplying the numbers. Example 3 multiplied by 1 equal to 3, 3 multiplied by 2 equal to 6, 3 multiplied by 3 equal to 9. So here I have given multiples of 3. 3, 6, 9, 12, 15 all are the multiples of 3. Now here I have given one example. 4 multiplied by 5 equal to 20, where 4 and 5 are the factors of 20 and 20 is the multiples of both 4 and 5. Understand everyone? Now, further we are going to study about prime and composite number. These both you all have studied in previous class. The number which have exactly two factors, 1 and itself, is called a prime number. Example 2, 3, 5, 7, 11, and so on. Here I have given an example, that is 13. It has only two factors, 1 and 13. Now, our next topic is composite number. The numbers having more than two factors are known as composite numbers. Here we have seen some example 4, 6, 8, 9, and 10 are the first few composite numbers. Now, I have given one example 12. Here 1, 2, 3, 4 are the factors of 12, that is more than two factors. So 12 is a composite number. Now, next topic is co-primes and twin primes. Co-primes. Students, do you know about co-primes? I will tell. Two numbers are said to be co-primes if they do not have a common factor other than 1. Example 2 and 3, 3 and 4, 4 and 5, 4 and 9, 8 and 15, etc. Here I am going to take one example 4 and 9. Factors of 4 are 1, 2, and 4, and factors of 9 are 1, 3, and 9. There are no common factors except 1. So this is known as co-prime. Now twin primes. Twin primes are the numbers that differ by 2. Example 3 and 5, 5 and 7, 11 and 13 and so on. Now proceed to our next topic, divisibility rules. My dear students, it is very important rules for division. Divisibility rules is a shorthand way to determine whether a given integer is divisible by a fixed divisor without doing the division. Here I have given some rules. So let's see. First one is divisibility by 2. If the last number is even, that is 0, 2, 4, 6, 8, example 24. That is 4 is divided by 2. Means here I have taken 4, the last digit, and that it is divisible by 2. This implies that 24 is also divisible by 2. Now divisibility by 3. If the sum of the digits is divisible by 3, then the number is also divisible by 3. Now I will take one example, that is 219. 2 plus 1 plus 9 equal to 12 divided by 3 equal to 4. Here 219 is divisible by 3. Now our next point is divisibility by 4. If the number formed by its digit in the tens ones place is divisible by 4. So here I take one example, 96,852. Here tens and ones place is 52, that is divisible by 4. So 96,852 is also divisible by 4. Now next rule is divisibility by 5. It is very easy. Now we have to check only last digit, that is 0 or 5. If last digit is 0 or 5, then it is divisible by 5. Example 195, 250, 355. These all are numbers divisible by 5. Now divisibility by 6. If the number is divisible by 6 by each one of 2 and 3, means, now I will take one example, that is 42. Now last digit is 2 in 42, so the number is divisible by 2. And the sum of the number, that is 4 plus 2 plus 6, means 4 plus 2 equal to 6, is divisible by 3. This implies that 42 is divisible by 3. This is clear that 42 is also divisible by 6. Now, next rule is divisibility by 7. If the difference between twice the ones digit and the number formed by the other digit is either 0 or a multiple of 7. Now we consider the number 6804, means 6804. Here, 4 is on ones place, so we double it. 4 into 2 equal to 8. Now we subtract 8 from other digits, like 680 minus 8, that is 672, and which is divisible by 7. Therefore, 6804 is also divisible by 7. Now, divisibility by 8. If the number formed by its digit in hundreds, tens, and ones place. Now we take an example. 79,152. The number formed by its hundred, tens, and ones digit is 152, which is divisible by 8. This implies that 79,152 is also divisible by 8. Now, next rule is divisibility by 9. If the sum of its digit is divisible by 9, now we consider an example. 65,403. The sum of 65,403 is 18, which is divisible by 9. So students, this implies that 65,403 is also divisible by 9. And this rule is as same as the divisibility by 3. Now, next is divisibility by 10. Students, it is very easy, because in this rule we have to only check that the last digit is 0 or not. So example 600, 750, 950, these are divisible by 10 because their last digit is 0. Now next point is divisibility by 11. If the difference of the sum of digits in odd places and even places is either 0 or a multiple of 11. Here we take an example. 90,728. Sum of digits in odd places equal to 8, 7 and 9 equal to 24. And sum of digits in even places, that is 2 plus 0 equal to 2. And their difference is 24 minus 2 equal to 22, which is divisible by 11. This implies that 90728 is also divisible by 11. Now our last point is divisibility by 12. Here we have to check that if the number is divisible by 3 and 4 both, then it is also divisible by 12. Here I consider one example. 324. Here 3 plus 2 plus 4 equal to 9, that is divisible by 3. And number formed by tens and ones place in 324 is 24, which is also divisible by 4. So 324 is divisible by both 3 and 4. This implies that it is also divisible by 12. Now these are some divisibility rules. Now let's check. I have given three numbers here: 168, 275 and 6000. So let's check the first number, 168. Here in first number 168, its last digit is 8, which is divisible by 2. So 168 is also divisible by 2. Now let's take out the sum of all the digits. 1 plus 6 plus 8 equal to 15, which is divisible by 3. This implies that 168 is also divisible by 3. Now for 4, we have to find the number formed by ones and tens place. Here the number formed by ones and tens place is 68, which is divisible by 4. This implies that 168 is also divisible by 4. Divisibility by 5. Now we can see here that its last digit is neither 5 nor 0. So it is not divisible by 5. So I have written here no. Now 168 is divisible by both 2 and 3, so it is also divisible by 6. For the divisibility by 7, we have to double the ones place, that is 8 equal to 8 into 2 equal to 16, and subtract it from other numbers, means 16. 16 minus 16 equal to 0, and we get 0 here. So 168 is divisible by 7 according to the rule. Now we will check the last number, means 168 divided by 8 or not. So we will check its hundred, tens and ones place, that is 168, and it is divisible by 8. Like this example, you will try other two examples, that is 275 and 6000. Okay. Now our next topic is prime factorization. Students, do you know about prime factorizations? The product of prime factors is called prime factorizations of the number. There are two methods to find prime factorization. First one is factor 3. Now here I have given one example. See in the picture, 36 is given. We have to find two numbers when multiplied together give us product of 36. So let's start with 2 and 18. Now we have to split 18 in 2 and 9, and again we have to split 9 into 3 and 3. So here we get some prime factors, that are 2, 2, 3 and 3. There are 4 prime factors we got. Okay, so the prime factorization of 36 is 2 into 2 into 3 into 3. Now second method is division method. Now we see the example, there is 32. We have to choose smallest prime number which divides the number exactly. So I have choose here 2, and again we have to do it till the quotient becomes 1, like given in the picture. Understand everyone? Okay. Now we all studied about HCF in our previous class. So here we have given three methods to find the HCF. So, students, do you know the full form of HCF? Yes, you all know that HCF equal to highest common factor. Highest means the largest common factor, means the factors which are common in all the numbers. So, let's start with its definition. The greatest number which is a common factor of two or more given numbers is called highest common factor, that is HCF. So there are different methods to find the HCF. First is listing method. In this we all find the factors of both numbers 20 and 35, and then we see the common factors in both of them. Here I found the common factors are 1, 2, 4, 5, 10, and 20. Now we have to find the greatest among all the common factors, and the greatest are 20. Here 20 is the greatest. So 20 is the HCF of 20 and 35, both the numbers. Okay? Understand? Now, next method is prime factorization. Now we divide 64 and 80 and take out the factors. Then we identify the common factors. Here, as shown in the picture. See, the common factors are 4, which are 2, 2, 2, 2. Now let's multiply this. 2 multiplied by 2 multiplied by 2 multiplied by 2 equal to 16. So here the HCF of 64 and 80 is 16. Understand? Now the third and the last method is division. We have to find the HCF of 60 and 72. There are some steps to follow. Here we divide both the numbers by common factors only, and we have to divide them together. Okay? So here we divide both the numbers and stop dividing when there are no common factors except one. We have to find the product of common factors. So here in this example common factors are 2, 2 and 3. So we have to find the product. 2 into 2 into 3 equal to 12. So the HCF of 60 and 72 is 12. Understand? Now here we have to find the HCF of large numbers. So do you know, students? Now let's see. We will find the HCF of large numbers by division method. We divide the greater number by the smaller number, then make the remainder the new divisor and the original divisor the new dividend. Repeat the process until we get 0 as the remainder. Now the last divisor is the required as given in the example, that is 6, and 6 is the HCF of 30 and 42 according to the given picture. Now our next topic is LCM. LCM means least common multiple. You all know about LCM. You all have studied this in your previous class. The LCM is the smallest number, that is the multiple of all the numbers. Here I have given first method, that is listing method. So here we have to find the LCM of 5 and 6. So the multiples of 5 are 5, 10, 15, 20, 25, 30, 35 and so on. Same the multiples of 6 are 6, 12, 18, 24, 30, 36 and so on. But here the common multiple in both the multiples of 5 and 6 is 30. So the LCM is also 30. Understand everyone? So the common multiple is 30. That is the LCM of 5 and 6 is 30. Now second method is prime factorization. Here we take the example of 24 and 90. Now prime factors of 24 are 2, 2, 2 and 3. And same the prime factors of 90 are 2, 3, 3 and 5. Here we see common factors in both are 2 and 3. And then the left numbers are 2, 2, 3, 5. So for finding the LCM, we will firstly return the common factors. That is 2 into 2 into 3. Then again we have to write all the other numbers that are not in common. So 2 into 2 into 2 into 3 into 3 into 5. So LCM is 360. Now the third method is division method. We have to find the LCM of 20, 30 and 40. So let's see. I have written the given numbers as shown in the picture together and divide them with least prime number. If any number is not divisible by its respective divisor, it is to be written as such in the next line. Now keep on dividing until we get 1 as shown in the last row. Now we multiply all the divisors to get LCM. So here LCM is 2 into 2 into 2 into 3 into 5, that is 120. So the LCM of 20, 30 and 40 is 120. Understand everyone? Now let's do them some activity. I have given some questions here. So let's do it. First question is find the first three multiples of 8. So students, do you know about multiples of 8? Yes, we have studied now. 8 into 1 equal to 8, 8 into 2 equal to 16, 8 into 3 equal to 24. So the first three multiples of 8 are 8, 16 and 24. Now, second question is find the missing factors. Okay, here 7 into blank equal to 56 and we have to find the missing factor. I have written 8 here. Why? Because when we multiply 7 by 8, then we get 56. And same in question second, when we multiply by 6, we get 30. So here in first part 8 is the missing factor and in the second part 6 is the missing factor. Now our third question is encircle the prime numbers. Here I have given some numbers. From these numbers we have to encircle the prime number. So I have written prime numbers in the given numbers are 31, 59, 73, 97 and 37. Understand students? Same as you all have to do different questions in your home. Now, next question is find the SCF and LCM of 117 and 221. So let's find. Here we take out the factors of 117 and 221 as shown in the figure. So the factors of 117 are 3, 3 and 13 and the factors of 221 are 13 and 17. Here the common factors in both of them is 13. So the HCF is also 13. Now we have to find LCM also. So for finding LCM, firstly we have to see the common factor, that is 13. So I have written 13 here. 13 into other numbers we have to written as it is. So 13 into 17 into 3 into 3. So the LCM is 1989. Understand students? Now let's our next question. So students, our next question is find the SCF of 70, 80, 120 and 150. Now we take smallest number 70 and divide 80 by 70 as shown in the picture. Then we obtain 10 as remainder and divide 70 by 10 as same as now other numbers means 120 and we divide 120 by 10 up to we get remainder as 0. Now we also have to divide 150 and in both the cases 120 and 150 we got remainder 0 when we divide it by 10. So the last divisor is 10. Therefore the SCF of 70, 80, 120 and 150 is 10. Thank you students. Please like and share the video and don't forget to subscribe our channel. Okay? Bye everyone. Take care.